Hello everybody, this is Maurizio Martignano from Spazio IT, and this is the second video of the series applying the SAFe toolset to the Crazyflie code-based example. In this second video we're going to talk about the concept of Compilation Database, and in order to do that properly we need some background information. When doing software verification and validation, we usually perform static analysis. That is, we run static analyzers, and the more of them we run, the better. But the problem is that each one of these tools has its own format for specifying how to configure the system, how to run the compiler, its own way of specifying the sources, the include directories, the defines, and things like that. So configuring all these tools is if not a major task, is for sure a very tedious task. And this is why Spazio IT has developed an utility called Static Analysis Facilitator, for short SAFacilitator, whose major purpose is to simplify and make it easier the activity of configuring the static analyzer so that they can be run properly and produce useful analysis results. Only recently, compilers vendors and static analyzers vendors have started to try to converge on a common format for specifying the commands to give to the compilers and the build tools. If we Google Compilation Database, the first hit we get is this JSON Compilation Database format specification, which is a specification designed by the CLang and LLVM community. This compilation database format is a first attempt to specify in a tool-independent way how the various tools, the various compilers, the various build tools have to be called, have to be invoked to generate the system that we want to build. So this is very important, and it's a format that, of course, being developed by CLang and LLVM, is respected by the CLang static analyzers, that is CPPCheck and CLang tidy. All the other tools have just started this activity of standardization. They claim they can do it, but the fact is that at the moment very few of them can do it properly. As an example, let's take CPPCheck. If we look at the help documentation of the tool, CPPCheck, -help, and then we run less to explore the documentation, and we look for project. We can see here that the tool supports the compile commands.json file, so the compile database, the compilation database format. Okay. But this is just a claim, it's not working. If we try CPPCheck -project, and then we give to it the compile commands we just generated in the previous video, compile commands.json, this is what we get. So basically the tool is not able to read the compile commands.json file. Why? Because basically lots of tools have understood the importance of the compilation command format, but they're still not really able to adhere to it, to use it properly. Okay, so this is the current situation. And as we saw in the previous video, there are different tools able to generate this compilation database. One is CompileDB, and it's inside the virtual machine. The other is called Bear, and CMake itself can generate the compilation database file. So going back to the SAFacilitator, of which Marvin the press robot is an iconic representation, this is the picture we have. We have an application that is able to concentrate in a single container all information about a project. And then this utility, this tool, is able to generate in a automatic or almost automatic way all the data files, all the configuration files that are required to run properly the static analyzer. So we are able to run PCLint, CPPCheck, CLang check static analyzer, CLang tidy, the compiler itself. And we're also able to drive and in a proper way SonarQube to see the results. Of course, with this utility we can start from scratch from an empty file, or we can start from an already existing compilation database, from an already existing compile commands file, and convert it and edit it properly so that it becomes usable. So what we are going to see in this video is this process, starting from an already produced compile commands.json file and working with the SAFacilitator to produce a properly behaving a normalized compile commands.json file. And this is what we're going to see. So here we have the compile commands.json file generated in the first video. So we call up the static facilitator, and we should be able to see it in a while. So here we have the running SAFacilitator. We create a new project, and so now we edit the project information. So the project name will be naturally Crazyflie. The project key is something required by SonarQube, so we enter it like this: my Crazyflie. The version info Crazyflie. The version information, we saw that in the first video, was 2019.02, and then we put minus SAF to remember that this has been done by the SAFacilitator. And then we look for the directory where all the software is, so we look for it, and it's in this Crazyflie directory, so we select the directory. And we don't know nothing at the moment about the source directories, the source files. We don't know anything whatsoever about the compilation. We can already say something about SonarQube, so we put here the SonarQube URL, which is http://localhost, and then it's on port 9000. And we say something also about the Sonar scanner. We will see a lot about all these things and these parameters in either in this video or in the next one. So at the moment we just write this stuff in here, just opt Sonar scanner, and then bin and Sonar scanner. Okay, let's check that everything is perfect. Okay, so we go back to general and we're happy. Now we save this project, save project, as just crazyflie.json. I already had a file like that, so we're going to rewrite it, so save it. And we of course replace the previous one. And now again, if we look at the project information, we just put in some general information about the project, about Sonar, but we don't have any information whatsoever about the files to be treated, to be worked on, and the compilation stuff and so on. So what we can do now is to import into the project what was produced during the compilation via the compile-db command. So we import the compilation database. This one here, we import it. Now if we edit the project and we look for the information that previously was empty, now we see that we have the source directories taken from the compilation database, we have all the sources files, we have all the compilation options and things like that, and of course nothing has changed at analysis level. So if we look here for the moment at the compile commands.json file, this is basically a JSON list of pieces of information that are kept at file level. So per each file, we have the directory where the file is located, the quote-unquote argument, that is the name of the build tool, the compiler, you see the defines, other directives of the compiler, things like that. And then eventually we have the output that needs to be produced for that file and the actual file path name of it. And this information is kept on a file basis. So for each of the files in the make file, in the compile underscore commands.json file, that is in the compilation database, we have this type of information. This information has been collected by the SAFacilitator and it's reproduced in here. Okay, and of course here we see a kind of summary, but the utility is also able to show the actual information at file level. If I double click on a file, I'm going to see this panel that is kind of similar information, but this is the information specific for this file, okay, for the list.c file, which could be different compared to other similar information for other files. Okay, so this is what we get extracted from the compilation command database. Is this going to be useful for our analysis? Is it going to be good for our analysis? Let's suppose that it is. So we do this. We save it the way it is. And let's try, for instance, to generate from this information, to generate the SonarQube script, and to run from here already the passing of information to the SonarQube script. So we do that. Here we are calling a thing which is a Sonar scanner, which is a kind of web client talking to the SonarQube server and passing to the Sonar server all information about the project, all information that has been written on a configuration file generated by the SAFacilitator starting from the compilation database file. So now it got basically lots of rules from the server. Now should we start looking at the project configuration, and probably it will find some issues. So now it's reading the project configuration, and it found some issues, as we can see, and I'm going to read it so that we can understand it better. It says that a particular file, this exptest.c, according to the configuration, is included twice. So there is a problem, and we need to understand what is the cause of this problem. Okay, so we can clear the log. We can go back to editing the project, and we can look at the files. Okay, now there are several tools, like for instance SonarQube itself, but also CPPCheck, for example, that they look for sources starting from a particular directory, from a particular folder, and then they kind of do a descendant visit to that folder, looking for sources not only in that folder but also in all the children of the folder and the children of the children and so on. Okay, so if I have a file at a given level, say the child of a folder, then I cannot put twice that file. If I put the folder itself and the children folder, then that particular file will be listed twice. So we need to be very careful in how we specify the source directories. In order to do that, we better sort all these sources to understand if we have children. So what we're going to do is that we're going to cancel this. We're going to open a new project, which is something I already did, and it's basically the same information where the source directories have already been sorted. Here they have been sorted using the up and down command, and we can see that there are kind of a potential problematic situation like this SRC test, and yeah, this one SRC lib free RTOS, and here SRC lib free RTOS portable GCC. So basically, in order to correct this problem, we need to remove all the useless children, and this is something we have to do. Okay, so this is the first step. So we go again to the general view, we cancel this, we load our original project, okay, which was this JSON without Crazyflie JSON, and in here we edit again the project. Should be still empty because I didn't save it before, so we import again the compilation commands. And now we're back to the situation where we were before. So if I edit the project, we see the files which have still to be processed properly. Another source of problems, of course, are the compilation options. Why? Because here we are using a cross compiler, the ARM non-EABI GCC. This is an embedded GCC compiler for the ARM processor. So some of these things are not right. So basically what we need to do, apart from correcting the source files, we also need to remove all these particular options which are typical of the ARM processor. So we can take them out like this. Let's see. Okay, we can stop here. And of course we need also to remove W error. Why? Because this is something that says the compiler to stop whenever it finds a warning. We don't want that, because we want the compiler, the analyzer, to be able to continue its analysis also when they find problems. So we take this out, and this is an editing at general level. Now we press this button, with kind of flows all these changes to all various files in a single way. So we go back to the general and we save it. Okay, but we had again the problem with the sources. So now we take again the similar project where the source directories have been sorted, and they also have been treated properly, normalized, so we don't have duplications with the father-child relationship. So we take this one, the Crazyflie without duplication, and we check if also we are good in terms of defines and compilers options. I think we are. So we should kind of be okay. Okay. So in order to verify that everything is working well, what we can do is that we can select to use a particular analyzer, for instance the SAFacilitaor static analyzer, like in this case. Okay, and we save the project. And what's this one? Now, of course, we replace it, no problem. Now we see if the SAFacilitator is able to properly configure and run this particular static analyzer. So we prepare the scripts and the configuration files for the SAFacilitaor static analyzer, and then we execute it. Okay, so we execute it, and this is going to take a long time. So what we're going to do is that we stop this process and we look at the partial results. So in a moment the process will be stopped and we will be able to see the results in here. And this is the standard error of the process. We see that the static analyzer is doing some checks, but the static analyzer is also complaining about some compiler options still present in the command. You see, it says, look, this argument given to the compiler, to the static analyzer, is not used, is not known. These are stuff referring to the ARM processor. But we did remove these options from the configuration. So what is happening? What is happening is that if we look at the generated file, we have generated this crazyflie.clang, so we can have a look at it. It's pretty big. These are all the options passed to the CPPCheck analyzer. In here we can't see the options that the analyzers was complaining about. From where do they come from? Not from here. Point is that we still have in the directory the compile commands.json file, the original one, the one that has not been normalized. Okay, so whenever the CPPCheck static analyzer or CPPCheck they run, they ignore the parameters that have given to them via the command line, but they read the parameters from the compilation database file if it is present. So if we want the static analyzer and the CPPCheck to properly use our configuration options, we need to update to normalize the compile commands.json file. So what we have to do is very simple. We go back to our SAFacilitator, we clear the log just to be a bit clean in our execution, and what we do is that we save the project as compile commands. So now we're going to rewrite basically the original compile underscore commands.json file. So now the file is not any longer the one generated by the compiledb utility that we used in the first video, but it's a new compilation database generated according to our basically our instructions, our configuration. We can check here, prepare again the analyzers, execute them. Only we just do this with this particular analyzer because just we need to check that everything is working. Again, we stop it after a while because now we just want to see that everything is correct. And now we see here only the warning from the code analyzer that is spotting something is not properly done inside the code base. So we are okay. So going back to where we started, we create the log. We go back to where we started, and we can see that basically we started from an empty project. We put some information like general information about the project and the analysis. Okay, we had this information empty. We got it from the originally generated compilation database file. We had to clean it a bit. In particular, we had to fix the directories, and we had to fix basically the compilation arguments, like the defines and some of the arguments. Okay, and now that everything is okay, we tell the tool that we want to run all the analyzers. We save it, and we save this as our initial project, which now is properly configured. So now in the crazyflie.json file, we have a project with all required information properly configured and able to run the tools in a proper way, and we save it. So we exit, and this is the end of the second video. Thank you very much for having listened to this video.